Hey YouTube, welcome to another video. In this cursory episode, I will show how I use OpenSense to integrate with TP-Link Umada platform. By the way, before you spend time watching this video, I just want to say that when it comes to pfSense or OpenSense, I will not even call myself a newbie. I'll say it up front that I don't know what I'm doing and I'm just following the documentation on the official site. But while I don't really need it, a lot of people have sworn how great this product is, especially when it comes to the firewall rules. I also received a few inquiries regarding this, and most of the time, it is about replacing the TP-Link Umada gateway. But my take on this is a little different, simply because I look at the Umada gateway as an internet and VPN gateway with firewall capabilities, and OpenSense as a firewall with VPN and routing capabilities and powerful network services such as IDS and IPS, as well as multiple DNS servers. And since OpenSense is a fully featured firewall, I look into its mode of operations. I found out that it can operate not just in a typical firewall router mode, but also in firewall transparent mode. As a transparent firewall, OpenSense will function like a switch, which can inspect packets and forwards or deny not only based on MAC address, but also use its rich firewall rules to make those decisions. And this mode is the one that I'm most interested in, since it will allow me to have this device to coexist with TP-Link devices and easily integrate as another network device in the Umada network environment. And in this video, I will show how I achieve that. So this is where you can see how the typical setup for OpenSense is usually happening. It's the firewall and a router at the same time for many home networks. And in the case of a transparent bridge, this is usually the setup. Basically, your ISP goes to your firewall, then to your internal home router. However, for this video, this is how I have it set up. I have the gateway, and then I have the firewall, and then I have a layer 3 switch. And the reason I have it set up like this is to allow more granular control between separate layer 3 environments. So what do I mean by that? Something like this. If I have the firewall set up at the top, meaning all traffic will have to go through that. I'm not saying that's a bad thing, except that that's not my preferred approach, and I would like to have it something like this, so that the firewall can protect LAN under it, even from the internal networks or anything below the gateway. This way, you can also set custom firewall rules based on the other IP networks that you have within your control, within your LAN networks. So in my planned use of this box as a firewall, I'm not using its capability for VLANs or routing traffic. My goal is to set up this box as a basic transparent bridge, and from there, network admin can make firewall rules based on their requirements. Note that while this basic setup will not touch any of the Umada configurations, this setup will add a level of complexity to your overall network simply because you are introducing a new device. So how do you set it up? So for those who are new like me or is not aware of what OpenSense is, they have a pretty good website in here. You can see it's at opensense.org. This is the website of the OpenSense software or application. I will add the link into the description, and this is the website where you will find all the needed information to set it up and configure. So let me just jump into the download part of it. So just make sure to select the proper build and image for your computer. In my case, I will be using an x86 computer, so I selected AMD 64 and then VGA, and then I selected the mirror location and I proceeded to download it. Now that you know where the website is, let's start from the very beginning. For this experiment, I chose to do the DIY route and used my own spare hardware. This is the bare minimum requirement and a reasonable requirement, but for my own build, I'm using an old HP compact small form factor with the Core i5 2400, 12GB of RAM, 128GB of SSD, and one onboard network interface card. A spare USB flash drive is also needed for initial boot up and setup. Since this project requires at least 2 NICs, I got another network interface card with an Intel 82574L chipset. I chose this network interface card because the chipset has been available for more than 10 years now, which means that the driver should be available and stable. I chose that because I'm really new at this and I can't afford to spend too much time hunting for drivers and troubleshooting it. Besides, I only need 1 gigabits per second additional LAN port for this weekend project. It is also very useful to have a keyboard, mouse, and monitor directly attached to the PC that you're building rather than doing it remotely. So now let's move on to preparing your installer media. So first, download the proper image to your computer, then make sure you unzip the downloaded file and take note of the folder. And then the next step is to burn the files to your USB flash drive. In my case, I use a Balena etcher, but you can also use Rufus or other similar applications to burn the image to the USB flash drive. After you have prepared your installer media, the next step is to install that software. So first, boot up your PC using the USB flash drive. It will boot up and you will see all the messages on the screen. So just log in with the username installer and the password should be OpenSense. So that will be OPNSENSE. This will launch the installer, and in my case, as you can see on the screen, I followed all the default selections, and then close to the end of this step, you will be prompted to change the password. Note that once you change the password, it will go back to that same screen. You don't have to enter your password again, so just select the other option to complete the setup and reboot the PC. Once the installer has completely closes and the PC went back to the boot screen, remove the USB flash drive so that your PC will properly boot from the SSD. So now the next step is to set up the default out-of-box configuration for OpenSense. So you have installed it, now you have to configure it. So once the PC has rebooted, it will prompt for login. So just log in normally using the username root and the password that you set during the setup process. And once you have done that, you will see that it will display a series of numeric menus as well as its default IP address of 192.168.1.1. Since I am integrating it to my Umada network environment, I need to change the IP to 192.168.101.10. This IP address is tied to the onboard NIC, which is my OpenSense LAN interface. Make sure to connect this cable in one of the access ports in the admin VLAN 1 profile in any of your Umada access switches. I then used a different PC and used a web browser to connect to the OpenSense console. Note that OpenSense is still a router, so you need to make sure your PC is connected to the admin VLAN. Meaning, the PC and OpenSense firewall needs to be in the same IP network. Log into the management console and follow the wizard and you're done. So at this juncture, you now have a fully working out-of-the-box OpenSense firewall. And the reason for this is because this is the required baseline configuration to start configuring it as a transparent firewall, which is the final step of this guide. So we are now at the last leg of the configuration, which is really focused on getting OpenSense configured as a transparent firewall or as a bridge firewall. So in this part of the video, the background video playing is me exploring how to configure the transparent firewall mode. You can see me going back and forth with the configuration because I am new to this. Another reason is because the interface has changed. So what I'm going to do is put emphasis on some areas of the video so that you will know how I did it in this current version of the software. As I have mentioned, the requirement is to have a basic OpenSense configuration. From there, I followed the guide closely. By the way, one of the tips on the guide is to not hit apply. In my setup, I didn't think any of them could have caused any issue except the later part of the steps. But I still hit apply after each step that requires it. I always hit save as well. I will also do some minor commentary on how I understood each step. So let's get on with it. The first step is to disable outbound NAT rule generation. To do that, go to firewall and then NAT and then mode and then disable outbound rule generation. Hit save and apply. This makes sense since this will be a transparent bridge. There is no more distinction between LAN or WAN. It's just two NIC ports coming from one port to another. The second step is to change the system tunables. I'm not sure how to say it, but I say it tunables. This step is to enable the packet filtering on the virtual bridge and not on the physical interface. So two tunables needs to be changed. The first tunable is the net.link.bridge.pfill_bridge and set it to 1 to enable bridge filtering. And the second tunable is the net.link.bridge.pfill_member and set it to 0 to disable filtering on the physical NICs. Make sure you do a save each time just to save yourself some heartache. The third step is to create the virtual bridge by selecting the interfaces. This step threw me off since the UI has changed, but this step can still be done by going to Interfaces, Other Types, Bridge, and then hit the plus symbol on the upper right corner. And then on the window that will pop up, select the LAN and WAN interfaces from the drop-down, then click Save. Think of the bridge as your SVI. The fourth step is to assign a management IP. This is to ensure that you can still reach this device. As with anything about IP, make sure you don't have any conflict. I used 192.168.101.30 for mine. The UI has a slight change, but you can find these settings by going to Interfaces, Assignments, assign a new interface, and then click Add. Make sure to give it a good description because this description will appear as the name of the bridge on the left menu navigation. Once you save and apply, like I said, this third interface will become selectable under the same interfaces menu. Next step is under basic configuration, make sure to enable this virtual interface. Then scroll down to generic configuration. Under IPv4 configuration type, select static IPv4, and then after that, scroll down even more to static IPv4 configuration and assign an IP address to the IPv4. I used that /24 subnet mask on mine and then saved and applied the changes. Next step is to disable block private networks and bug on. Because your WAN NIC is not necessarily facing a WAN area anymore, it does not need to do a typical WAN stop. To do this, uncheck both options shown on the image. Go to Interfaces, WAN, Generic Configuration, Block Private Networks. And then another one is under Interfaces, WAN, Generic Configuration, Block Bug on Networks. These two should be on the same page, so you can uncheck them both at the same time. Hit Save and Apply. Halfway through, the next step actually didn't apply to me because when I changed the IP during the initial configuration, I did not enable DHCP server. But this step will allow you to disable your DHCP server. So if you need to disable DHCP server, go to Services and then go to ISC, DHCP v4, and then go to LAN. Then uncheck the Enable DHCP server on LAN interface as shown on the image. For the next step, the guide says it can be skipped. But to make sure I will not be hampered, I just did everything as well. Personally, I believe you need to absolutely add the allow all for the virtual bridge interface just to make sure you are not blocking anything. When you are more familiar with how the OPNsense works and how everything works together, you can make all your custom rules later on. So to do this, go to Firewall, Rules, and then select each interface. So for example, LAN, WAN, and Bridge. When I was making those rules, I always click the plus sign and then direction and then in and save, and then I create another one. So I click the plus sign again, direction is out, and then save. Make sure to do this for all your interfaces, both virtual and physical. So the next step is to disable the anti-lockout tool. This is a protection for the LAN interface, so this can be safely skipped. Just like that there is no more WAN facing NIC port, the LAN facing NIC port is not existing anymore. Both of the physical NIC ports are just physical NIC ports that are not really belonging to either WAN or LAN. The bridge will be the star of the show. I still did this though because just to get myself more familiarized with the system. So if you would like to get more familiarized with the system, just go to Firewall, Settings, Advanced, and then just do a Control F to find this particular option. Disable anti-lockout. So you're almost home run for this next step. Since you're always doing a save and apply just like I do, it's pretty much almost done once you finish this step. But this is the step wherein it gave me a little bit of pause because I was worried that I will lose access to the device. But I still have my trusty keyboard and mouse and monitor attached to it, so I just went on with it anyway. But I found out that you don't necessarily have to do it. But again, to get myself familiarized with the system, I just configured it. Basically, since all the processing now happens on the virtual bridge, there is no need to assign any IPs for the interfaces, for the physical interfaces themselves. For example, for LAN, the IP is used to access the management console for the very first time, like what we're doing right now with my Media PC. And for WAN, for making your WAN services available from the internet. But since this device works like a super smart switch now, there is no need for IP addresses for the physical interfaces. If you want to disable it, go to Interfaces and then LAN and then head on to Generic Configuration section, IPv4 configuration, and then type none and then hit save. And then do the same thing for WAN. So Interfaces, WAN, Generic Configuration, IPv4 configuration and type, and then none. The next step is actually just to hit apply for everything. The whole step on the documentation doesn't really recommend you to apply, so that you can still always have full access to the device, which is the safest approach. But in my experience, everything worked well, so it's really up to you. But like I said, this step is just to hit apply and everything is done deal. So after this, your device is now transformed into a transparent bridge. Depending on how you have everything set up in your LAN, you can choose several steps to take. For example, if you have an ER605 version 1, or even if you have an ER605 version 2 Umada gateway, you can choose to turn off its IDS and IPS on that box. You can delegate this box, the OPNsense box, to offload the IDS IPS functionality to the OPNsense box. So hit services, followed by intrusion detection, then followed by administration. Click these options here and then hit apply. However, if you have a really beefy Umada gateway, then you can leave these two functionalities on the Umada platform so that you have a one-stop shop for doing IDS and IPS, and just use OPNsense for something else. And with that, the OPNsense Transparent Bridge is fully configured, and the final task will be to get your Transparent Bridge physically connected to your Umada network. And now for the final task of this video, I will show how to use this OPNsense within the Umada environment. As you can see on the screen, I decided to reboot all my devices. This is just to make sure that there will be no issues or conflict within my devices. And as you can see on the mini video, I have connected the ER605 gateway to the OPNsense bridge NIC port. This connection used to be between ER605 and SG2008. I then connected my SG2008 layer 3 switch to the other NIC port of the OPNsense bridge. Remember that you have to imagine this OPNsense device as a two-port switch, which means it doesn't matter which NIC ports connects to which device so long as there's no loop. So the ER605 can connect to the LAN port or to the WAN port, and just the same for the SG2008. It can connect either to the LAN port or the WAN port, and the results will be the same. But for consistency, I decided to connect the WAN port of the OPNsense bridge to the ER605, and I decided to connect the LAN port of the OPNsense bridge to the SG2008 uplink. This connectivity used to happen directly between the ER605 and the SG2008. As for testing, in the video you will see me pinging google.com with the new OPNsense bridge installed. It failed while the Umada devices are still booting, but once the devices came back online, I can reach the OPNsense web console by pinging 192.168.101.30. I also ping my Umada gateway, which is 192.168.101.1. And then I ping google.com and then proceeded to launch the OPNsense web console, and I'm able to log in successfully. As you can see on the screen, this is the final physical connectivity of all the devices that I have in the lab. I have the ER605 using the WAN port of the OPNsense bridge, and then the LAN port of the OPNsense bridge is connecting to the uplink of the SG2008. I think that's pretty much it for this video. If you like to see me struggle more about OPNsense, how I'm very new at this, or you can put that in the comments and let me know, hey RC, you're so newbie, this is the wrong way to do it, or this is the wrong implementations of OPNsense. Feel free to let me know, put that in the comments, and please feel free to school me with regards to OPNsense, or even with Umada, or even with networking in general. I'll be glad to learn more and expand my knowledge when it comes to networking. So thank you again for watching my video. I'll see you in the next one. Thank you and bye bye.